I'm here to enlist you in helping reshape the story about how humans and other critters get things done. Here's the old story. We've already heard a little bit about it. Biology is war, in which only the fiercest survive. Businesses and nations succeed only by defeating, destroying, and dominating competition. Politics is about your side winning at all costs. But I think we can see the very beginnings of a new story beginning to emerge. It's a narrative spread across a number of different disciplines in which cooperation, collective action, and complex interdependencies play a more important role, and the central, but not all important role of competition and survival of the fittest shrinks just a little bit to make room. I started thinking about the relationship between communication, media, and collective action when I wrote Smart Mobs, and I found that when I finished the book, I kept thinking about it. In fact, if you look back, human communication, media, and the ways in which we organize socially have been co-evolving for quite a long time. Humans have lived for much, much longer than the approximately 10,000 years of settled agricultural civilization in small family groups. Nomadic hunters bringing down rabbits, gathering food. The form of wealth in those days was enough food to stay alive. But at some point, they banded together to hunt bigger game. And we don't know exactly how they did this, although they must have solved some collective action problems. It only makes sense that you can't hunt mastodons while you're fighting with the other groups. And again, we have no way of knowing, but it's clear that a new form of wealth must have emerged. More protein than the hunter's family could eat before it rotted. So that raised a social question that I believe must have driven new social forms. Did the people who ate that mastodon meat owe something to the hunters and their families? And if so, how do they make arrangements? Again, we can't know, but we can be pretty sure that some form of symbolic communication must have been involved. Of course, with agriculture came the first big civilizations, the first cities built of mud and brick, the first empires. And it was the administrators of these empires who began hiring people to keep track of the wheat and sheep and wine that was owed and the taxes that was owed on them by making marks on clay in that time. And not too much longer after that, the alphabet was invented. And this powerful tool was really reserved for thousands of years for the elite administrators who kept track of accounts for the empires. And then another communication technology enabled new media. The printing press came along, and within decades, millions of people became literate. And from literate populations, new forms of collective action emerged in the spheres of knowledge, religion, and politics. We saw scientific revolutions, the Protestant Reformation, constitutional democracies possible where they had not been possible before. Not created by the printing press, but enabled by the collective action that emerges from literacy. And again, new forms of wealth emerged. Now, commerce is ancient. Markets are as old as the crossroads. But capitalism, as we know it, is only a few hundred years old, enabled by cooperative arrangements and technologies such as the joint stock ownership company, shared liability insurance, double-entry bookkeeping. Now, of course, the enabling technologies are based on the internet. And in the many-to-many era, every desktop is now a printing press, a broadcasting station, a community, or a marketplace. Evolution is speeding up. More recently, that power is untethering and leaping off the desktops. And very, very quickly, we're going to see a significant portion, if not the majority of the human race, walking around, holding, carrying, or wearing supercomputers linked at speeds greater than what we consider to be broadband today. Now, when I started looking into collective action, the considerable literature on it is based on what sociologists call social dilemmas. And there are a couple of mythic narratives of social dilemmas. I'm going to talk briefly about two of them, the prisoner's dilemma and the tragedy of the commons. Now, when I talked about this with Kevin Kelly, he assured me that everybody in this audience pretty much knows the details of the prisoner's dilemma. So I'm just going to go over that very, very quickly. If you have more questions about it, ask Kevin Kelly later. The prisoner's dilemma is actually a story that's overlaid on a mathematical matrix that came out of the game theory that in the early years of thinking about nuclear war, two players who couldn't trust each other. Let me just say that every unsecured transaction is a good example of a prisoner's dilemma. Person with the goods, person with the money, because they can't trust each other, are not going to exchange. Neither one wants to be the first one, or they're going to get the sucker's payoff. But both lose, of course, because they don't get what they want. If they could only agree, if they could only turn a prisoner's dilemma into a different payoff matrix called an assurance game, they could proceed. 20 years ago, Robert Axelrod used the prisoner's dilemma as a probe of the biological question: if we're here because our ancestors were such fierce competitors, how does cooperation exist at all? He started a computer tournament for people to submit prisoner's dilemma strategies and discovered, much to his surprise, that a very, very simple strategy won. It won the first tournament, and even after everyone knew it won the second tournament. That's known as tit for tat. Another economic game that may not be as well known as the prisoner's dilemma is the ultimatum game. And it's also a very interesting probe of our assumptions about the way people make economic transactions. Here's how the game's played. There are two players. They've never played the game before. They will not play it again. They don't know each other, and they are, in fact, in separate rooms. First player is offered $100 and is asked to propose a split. 50-50, 90-10, whatever that player wants to propose. The second player either accepts the split, both players are paid, and the game is over, or rejects the split, neither player is paid, and the game is over. Now, the fundamental basis of neoclassical economics would tell you it's irrational to reject a dollar because somebody you don't know in another room is going to get 99. Yet, in thousands of trials with American and European and Japanese students, a significant percentage would reject any offer that's not close to 50-50. And although they were screened and didn't know about the game and had never played the game before, proposers seem to innately know this because the average proposal was surprisingly close to 50-50. Now, the interesting part comes in more recently when anthropologists began taking this game to other cultures and discovered to their surprise that slash and burn agriculturalists in the Amazon, or nomadic pastoralists in Central Asia, or a dozen different cultures, each had radically different ideas of what is fair. which suggests that instead of there being an innate sense of fairness, that somehow the basis of our economic transactions can be influenced by our social institutions, whether we know that or not. The other major narrative of social dilemmas is the tragedy of the commons. Garrett Hardin used it to talk about overpopulation in the late 1960s. He used the example of a common grazing area in which each person, by simply maximizing their own flock, led to overgrazing and the depletion of the resource. He had the rather gloomy conclusion that humans will inevitably despoil any common pool resource in which people cannot be restrained from using it. Now, Elinor Ostrom, a political scientist in 1990, asked the interesting question that any good scientist should ask, which is it really true that humans will always despoil commons? So she went out and looked at what data she could find. She looked at thousands of cases of humans sharing watersheds, forestry resources, fisheries, and discovered that yes, in case after case, humans destroyed the commons that they depended on. But she also found many instances in which people escaped the prisoner's dilemma. In fact, the tragedy of the commons is a multiplayer prisoner's dilemma. And she said that people are only prisoners if they consider themselves to be. They escape by creating institutions for collective action. And she discovered, I think, most interestingly, that among those institutions that worked, there were a number of common design principles. And those principles seem to be missing from those institutions that don't work. I'm moving very quickly over a number of disciplines. In biology, the notions of symbiosis, group selection, evolutionary psychology are contested, to be sure. But there is really no longer any major debate over the fact that cooperative arrangements have moved from a peripheral role to a central role in biology, from the level of the cell to the level of the ecology. And again, our notions of individuals as economic beings have been overturned. Rational self-interest is not always the dominating factor. In fact, people will act to punish cheaters, even at a cost to themselves. And most recently, neurophysiological measures have shown that people who punish cheaters in economic gains show activity in the reward centers of their brain, which led one scientist to declare that altruistic punishment may be the glue that holds societies together. Now, I've been talking about how new forms of communication and new media in the past have helped create new economic forms. Commerce is ancient. Markets are very old. Capitalism is fairly recent. Socialism emerged as a reaction to that. And yet we see very little talk about how the next form may be emerging. Jim Surowiecki briefly mentioned Yochai Benkler's paper about open source, pointing to a new form of production, peer-to-peer production. I simply want you to keep in mind that if in the past new forms of cooperation enabled by new technologies create new forms of wealth, we may be moving into yet another economic form that is significantly different from previous ones. Very briefly, let's look at some businesses. IBM, as you know, HP, Sun, some of the most fierce competitors in the IT world are open sourcing their software, are providing portfolios of patents for the commons. Eli Lilly, in, again, the fiercely competitive pharmaceutical world, has created a market for solutions for pharmaceutical problems. Toyota, instead of treating its suppliers as a marketplace, treats them as a network and trains them to produce better, even though they are also training them to produce better for their competitors. Now, none of these companies are doing this out of altruism. They're doing it because they're learning that a certain kind of sharing is in their self-interest. open source production has shown us that world-class software, like Linux and Mozilla, can be created with neither the bureaucratic structure of the firm nor the incentives of the marketplace as we've known them. Google enriches itself by enriching thousands of bloggers through AdSense. Amazon has opened its application programming interface to 60,000 developers, countless Amazon shops. They're enriching others not out of altruism, but as a way of enriching themselves. eBay solved the prisoner's dilemma and created a market where none would have existed by creating a feedback mechanism that turns a prisoner's dilemma game into an assurance game. Instead of neither of us can trust each other, so we have to make suboptimal moves, it's you prove to me that you're trustworthy and I will cooperate. Wikipedia has used thousands of volunteers to create a free encyclopedia with 1.5 million articles in 200 languages in just a couple of years. We've seen that ThinkCycle has enabled NGOs in developing countries to put up problems to be solved by design students around the world, including something that's being used for tsunami relief right now. It's a mechanism for rehydrating cholera victims that's so simple to use that illiterates can be trained to use it. BitTorrent turns every downloader into an uploader, making the system more efficient the more it is used. Millions of people have contributed their desktop computers when they're not using them to link together through the internet into supercomputing collectives that help solve the protein folding problem for medical researchers that's folding at home at Stanford, to crack codes, to search for life in outer space. I don't think we know enough yet. I don't think we've even begun to discover what the basic principles are, but I think we can begin to think about them. And I don't have enough time to talk about all of them, but think about self-interest. This is all about self-interest that adds up to more. In El Salvador, both sides that withdrew from their civil war took moves that have been proven to mirror a prisoner's dilemma strategy. In the US, in the Philippines, in Kenya, around the world, citizens have self-organized political protests and get out the vote campaigns using mobile devices and SMS. Is an Apollo project of cooperation possible, a transdisciplinary study of cooperation? I believe that the payoff would be very big. I think we need to begin developing maps of this territory so that we can talk about it across disciplines. And I am not saying that understanding cooperation is going to cause us to be better people. And sometimes people cooperate to do bad things. But I will remind you that a few hundred years ago, people saw their loved ones die from diseases they thought were caused by sin or foreigners or evil spirits. Descartes said we need an entire new way of thinking. When the scientific method provided that new way of thinking and biology showed that microorganisms cause disease, suffering was alleviated. What forms of suffering could be alleviated? What forms of wealth could be created if we knew a little bit more about cooperation? I don't think that this transdisciplinary discourse is automatically going to happen. It's going to require effort. So I enlist you to help me get the cooperation project started. Thank you.
This is very prophetic because these are the exact technologies that have been deployed and that are spreading that we're going to be talking about. And exactly as was described in this video, this is how to obtain true net neutrality, real, actual net neutrality, and just as this guy said, in a way that has no requirements of politics and bureaucracy or any of that, where it won't matter what a small collective of terrorists called Congress voted on or not. You know, you're still here, Rich, right?
Yes, I am.
Yep. And so what we're going to do is basically he was talking about BitTorrent. Of course, you've heard of Bitcoin. These two technologies basically had a one-night stand, did some sexy time, and the end resulting offspring was ipfs, also known as the Interplanetary File System. ipfs is the distributed web, a peer-to-peer hypermedia protocol to make the web faster, safer, and more open. The web of tomorrow needs ipfs today. HTTP is inefficient and expensive. HTTP downloads a file from a single computer at a time instead of getting pieces from multiple computers simultaneously. With video delivery, a P2P approach could save 60% in bandwidth costs. ipfs makes it possible to distribute high volumes of data with high efficiency, and zero duplication means savings in storage. Couple of points I want to make on that. Number one, we over here at Paradigm Shift and Educational Comedy have started messing with ipfs, and I can vouch for how much faster both the uploads and the downloads appear to be on the ipfs system. And I also want to, now this is one of those things that's going to seem counterintuitive at first. There's going to be a bunch of different things that seem counterintuitive and almost contradictory at first, so I want to make sure I clarify good enough. When you see them say zero duplication, yet simultaneously, how is this protocol maintained? Duplication out the asshole, redundancy out the asshole, bits and pieces of fragments of files being duplicated and sent throughout the network to effectively make an infinite, ever-growing, limitless, a cloud drive. So it's like, wait a minute. If there's duplication out the ass, what does zero duplication mean? What they mean is that when you upload an entry into ipfs, it has its own what is referred to as a hash, basically an entry in the system. So they don't mean no duplicate files flying around in the background. What they mean is no duplicate entries. In other words, no confusing redundancy. Like there's various different platforms, like whether you're talking about Echo Mail or emails or social media posts or whatever, you can have an ungodly amount of duplicate entries all over the flipping place. When you upload something into ipfs, it has a system to avoid duplicate entries. Now, a single entry can be, accessed and put forth on any number of sites as you want to. It's not saying that, only one site has exclusive authorization to, put forth this one entry and fuck everybody else. What it means is you're not having all sorts of duplicate entries, and duplicate entries within a database can slow it down. Database slowdowns means you are basically using bandwidth as these databases are slowing down, because these databases are becoming increasingly more clunky and inefficient, and in the meantime you're using more bandwidth to do less, and it's messy. And so IPFS, the way it's designed, avoids that kind of mess, and hence, therefore, the 60% savings in bandwidth costs, and elimination of duplication, and da 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 da. Humanity's history is deleted daily. The average lifespan of a web page is 100 days. Remember GeoCities? Oh, and by the way, GeoCities got backed up to an archive which still exists. You can Google that. The guy who made the BBS documentary actually headed off that project, and without the project of archiving GeoCities, all that data would have been lost. But anyway, the web doesn't anymore. It's not good enough for the primary medium of our era to be so fragile. IPFS provides historic versioning like Git and makes it simple to set up resilient networks for mirroring of data. In other words, yes, initially, zero duplication, so you're not creating unnecessary duplication. But as far as backups are a good thing when you do them intentionally. So that's organized duplication. And with the organized duplication, you're doing it in such a way that it stays, it sticks, it's not getting nuked. So again, there's many different strategic layers to the level of efficiency that this sort of technology employs. The web centralization limits opportunity. The internet has been one of the great equalizers in human history and a real accelerator of innovation, but the increasing consolidation of control is a threat to that. IPFS remains true to the original version of the open and flat web, but delivers technology which makes that vision a reality. Our apps are addicted to the backbone. Developing world, offline, natural disasters, intermittent connections, all trivial compared to interplanetary networking. The networks we are using are so 20th century. We can do better. IPFS powers the creation of diversely resilient networks which enable persistent availability with or without internet backbone connectivity. Let me translate that one into English for people. I'm sure everyone has noticed, as have I, as has Richard. Have you noticed, Richard, that the more applications become increasingly, shall we say, for lack of a better word, cloud dependent, applications start slowing down, which then in turn slows down the browser, which then in turn slows down the computer itself. Ever notice how Facebook is becoming incredibly more and more laggy and inefficient and stupid, which then slows down the browser tab, which then starts to affect the browser as a whole, which then starts to affect the computer as a whole, regardless of whether or not you're running Linux or Mac or Windows or what the hell you're running. More stable operating system just means it can take the hit without collapsing imminently. But still, we're noticing that these sites, the more bells and whistles and cool shit gets added, it means the more each application needs to keep making more multiple simultaneous connections over the internet to different aspects of this technology, and it's creating the information superhighway traffic jam. Add on to that all of the various powers that be and hacking groups and stuff doing DDoS dickwag attacks all over the place, periodically turning the overall internet backbone into fucking Jello pudding.
Mm-hmm.
And this happening on connections where, like, I'm provisioned at 75 Mbps down, 10 Mbps up. On average, I get more like 13 Mbps up, 91 Mbps down. So even on those sick and obscene speeds, I'm not bragging, they simply just are sick and obscene. Even with that, I get slowdowns that bring me back, if you know what I mean. And I'm looking at it like, wait a minute, I've got all this bandwidth. Where are these slowdowns coming from? It's because all these different applications that are running simultaneously, all trying to make all their little connections to all their little points on the internet. It's like, imagine it being, 8 lanes worth of cars on a 2-lane highway. It's fucking ridiculous. And if the world was running IPFS as a standard all throughout, you wouldn't have this problem. IPFS aims to replace HTTP and build a better web for all of us. Now, by the way, just so you know, it doesn't mean that HTTP and HTTPS would go away. It means that it would be modified. In other words, like a new type of HTTP would be created. Kind of like when the Model A and the Model T went away, it doesn't mean that cars went away. We simply have cars that operate very differently than their predecessors. Okay, here's how IPFS works. Let's take a look at what happens when you add files to IPFS. Each file and all of the blocks within it are given a unique fingerprint called a cryptographic hash. That's that little identification I was referring to before. And by the way, I'm not an expert in any of this. I'm just good at recognizing patterns and then just doing my best to describe the patterns I'm observing. So please don't mistake me for being an IPFS expert. I'm really interested in this technology, but I'm still very much in my learning phases, and I'm doing the best I can. So I just want to make it clear to people watching, I am not an expert on IPFS, but I'm really enjoying what I've been learning. IPFS removes duplications across the network and tracks version history for every file. Again, refer to what I was explaining back before about duplications and databases. Each network node stores only content it is interested in and some indexing information that helps figure out who is storing what. I'm not fully entirely sure exactly what that means, so I can't comment fully. When looking up files, you're asking the network to find nodes storing the content behind a unique hash. In other words, the network knows who's got what. Every file can be found by human-readable names using a decentralized naming system called IPNS. IPFS is useful here and now. Archivists, it's not enough to organize the world's information. We need to store it in a way the world can remember it. IPFS provides deduplication, high performance, and clustered persistence. Again, as previously stated. Service providers. If your company delivers large amounts of data to users, a peer-to-peer approach could save you millions in bandwidth. IPFS can provide secure P2P content delivery. Researchers. If you're working with distributing and analyzing huge data sets, IPFS offers fast performance and decentralized archiving. Again, refer to everything that's been mentioned already. Developing world. High latency networks are a real barrier of entry to developing world. Refer back to the information superhighway traffic jams. IPFS provides resilient access to data independent of low latency or connectivity to the backbone. Blockchains. Bitcoin uses blockchains. IPFS and the blockchain are a perfect match. Basically, that's why I said, Bitcoin and BitTorrent had some sexy time, and, the bastard love child is IPFS. You can address large amounts of data with IPFS and place the immutable permanent IPFS links into a blockchain transaction. This timestamps and secures your content without having to put the data on the chain itself. Content creators. IPFS brings the freedom and independent spirit of the web at full force and at low cost. IPFS can help deliver content in a way which can save you considerable money. Okay, now going all the way back up, I'm going to go into a section that me and Richard were talking about last night. That's incredibly interesting. I was having a voice conversation with him about this, and now we can kind of do the on-screen stuff. Okay, where did I was I under documentation? Maybe documentation. Okay. Okay, where was this? Because remember, I had that listing of incredibly amusing, little explanation titles. Okay, where in the hell was this? I'm trying to find the place where I was before.
Oh, the go to sleep thing or whatever.
Yeah, the one they wrote it up really cute and funny. That shit was great. I'm trying to find my way back to that. Already API, maybe it was under getting started. Trying to relocate this back again. Still in the building from troubleshooting. Oh man, son of a gun, where was this? Yeah. Okay, I know it was here because I know I was on the main IPFS. Was it under watch demo? Maybe it was. No, that's the. Never mind. That's the video. That's not. No. Okay. I know I hit click try. So I went to this. Now where in the heck? Because I know I was in that documentation. I mean, you and I were discussing this last night.
Mm-hmm.
And I'm trying to go back to that documentation list. Okay. And remember, there was all those catchy, funny titles and stuff like that, and just the way they outlined it was funny. Okay, come on, we're going online. Onward to more. Maybe it was here. Maybe it was onward to more examples. Yes, there we are. Yes, DAGs and objects and blocks. Oh my, be the swarm, pinning. Roll your own IPFS. Oh God. Yep, totally. So let's see here. Remember, be the swarm, and that guy in that video that you shared was talking about swarm technology and all that. So they're using the terminology.
Mm-hmm.
Okay, this talks about the hashes and stuff. The IPFS add command will create a Merkle DAG Merkle out of the data in the files you specify. It follows the Unix FS data format. When doing this, this means that your files are broken down into blocks and then arranged in a tree-like structure using link nodes to tie them together. Given a file's hash is actually okay. Anyway, the point is you're taking a file, you're shattering it into a bajillion freaking pieces, sending that shit to the digital 0-point field, and the hash is a reference that allows Scotty to beam it all back together again without Captain Kirk ending up a big pile of poo.
Mm-hmm.
So yeah, so it's talking about creating blocks and so on and so forth. So this part I don't need to get into uber super detailed, because for the majority of you watching, it's going to be a whole big lot of who gives a shit. I only want to focus on the things that I can accurately translate to the average person, that things that are relevant to them, that they're going to give a shit about. Okay, let's check this out. So, okay, not really any much of a giving a fuck here. Okay, roll your own ipfs. Okay, cool. Making your own ipfs service. So, it basically goes just, into the basics. Just gives the outline of the basic structure in here, gives you a basic idea of how it is set up and how it is run. And it just, it shows you how to set it up and run it. So there's nothing uber ultra impressive about that documentation. Let's see, trivial snapshots with IPFS. Okay, that wasn't one of the key important ones. The interplanetary naming system. This, I think, is going to have some important shit. Okay. IPNS is a way to add a small amount of mutability to the permanent immutability that is IPFS. This is yet another one of those seems like a contradiction at first sort of thing, because obviously the whole point of IPFS is, you upload it to the network, each file gets smashed and duplicated and all that. You've got these, nice little hashy blockchains that tell you how to reassemble the data, and therefore it can't be censored. Once it's on IPFS, on the interplanetary, file system, it's on there forever, and those who would want to, censor or do anything shady or whatever are just shit out of luck, because it's there and haha, you can't take it down. Well, that's the immutable part of it. Now, obviously, you're going to need some level of mutability. Otherwise, how are you going to make changes to anything? I mean, you can't have things just remain absolutely static with no ability to change, but at the same time, you don't want it to be so freaking mutable that you can go in and censor everything and destroy everything, and the proverbial bull in the china shop. So this is kind of the viewing reality as a cake, not a light switch, and seeing how things, interact with each other as far as ratio of ingredients instead of the left, right, dick, wag, all or nothing sort of thing. So, this allows just a small amount of mutability, just enough to be able to, update your projects and do what you need to do. I mean, obviously, what would be the point of a website if you couldn't update it, right? I mean, that would kind of suck. So, it allows for the basic things that people kind of need to do, but without allowing shit to get so crazy to where, tyrants can just, come in and own all your shit and be like, ha ha. So, it allows you to store a reference to an IPFS hash under the namespace of your peer ID, the hash of your public key. The commands to set it up are quite simple. So, okay, it's explaining how to set that up. And now, if you resolve the entry again, you'll see the new object. So, yeah, it's just, here's the instructions of just showing you how to update objects on the back end. Obviously, once these systems become more advanced, this is all going to be back end stuff, and the applications that people will be using on the front end will be handling all that in the background. But this at least shows you how that data gets changed, and that there is a mutability aspect of it, and it just kind of again shows how it's not an all or nothing kind of thing. Modifying the bootstrap peers list. Okay. Get even more distributed. Yeah, play on words there. What this basically shows is that when you upload a website itself into the IPFS file system, kind of like how similar to, you have Linux, and then other Linux distros are created based on that, and then you could take that and create even more, and it just kind of expands out. Well, this kind of allows websites to do the same thing. Like, obviously, a lot of us are DeviantArt users, so like, imagine if hypothetically DeviantArt was designed to work exclusively with the IPFS system. So now imagine, not only could people take that data and like toss it up on their own like subdomains to be able to essentially make clones of the site. They wouldn't have administrative access to it, so it's not like they could go through and wreck it or anything, but they'd be able to allow that service to be provided on their little clone site. But on top of that, you could then add on to it, because there would be open hooks in it. So it's like, if you wanted to redesign it to like make it your own version of DeviantArt, yeah, you wouldn't be running the core of DeviantArt. All of that would be immutable. That core would not be able to be changed unless, of course, you made a copy of the core in such a way to where then, all right, you're not pulling off of the original. You're kind of doing your own thing with it and redesigning it as its own thing. But otherwise, you can, make your nice little add-ons and plugins and whatever to basically re-express the original site to do more than the original site can do, so on and so forth. So this kind of explains how you would do that, that sort of thing. I'm not going to go into the uber technicalness of it on that, because most people aren't really going to particularly give a shit. They're only going to care about what I just explained, that being, the point of all of that. So it would basically be allowing websites to have that kind of open sourcey flexibility of creativity, but without anyone being able to stick their dick in the original project, as it were. So kind of a have your cake and eat it too. IPFS for websites. A short guide to hosting your site on IPFS. Adding your static website to IPFS is quite simple. Simply turn on your daemon. Well, hit the on switch, really? And add the directory containing your website. So this is showing you how to add your website directories into IPFS, and you're seeing that, everything has its own little hash IDs, as was explained before. The very last hash next to the folder name is the one you want, and let's call it the site hash for now. Now you can test it out locally by opening http://localhost port 8080/IPFS/site hash. Now let me do a little bit of a translation here. Localhost means it's like the equivalent of saying I, like I or me or mine. Localhost is the computer that the shit is installed into. So just like every human being can say I, me, my, knowing that they're referring to themselves and not anybody else out there in the world, every computer can have localhost, otherwise also known as 127.0.0.1. So localhost always simply means the computer that the shit is installed to. HTTP is normally on port 80, so this is like an alternate port 8080, and what this web interface does is basically it is a gateway into the IPFS system, because remember what they were explaining earlier. IPFS is not HTTP. It is literally its own thing. It's just in order for everybody else to be able to utilize it, it has to have hooks into HTTP. So you run, a web script, a web server script that allows HTTP to hook into IPFS. So on that localhost 8080/IPFS, now you're basically telling that web script, that that HTTP application, you're saying, all right, we're going to hook into the IPFS network now. So everything after the /IPFS is, referring to data that's on the IPFS network. So loading that into your web browser. Next, to view it coming from another IPFS node, you can try http://gateway.ipfs.io/IPFS/site hash. Cool, right? But those hashes are rather ugly. Let's look at some ways to get rid of them. First, you can do a simple DNS text record containing DNS link equals IPFS site hash. Once that record propagates, you should be able to view your site at localhost 8080 IPMS your .domain. So like, you know, the elitesuckadick.com or hillaryisaskank.org.y, you know, whatever. Now that's a bit cleaner. You can also try this on the gateway at gateway.ipfs.io/IPNS/your.domain. Now this goes back to what I was saying earlier. The ipfs.io is obviously its own site. So from its perspective, it is localhost. So they have an interpreter mechanism in there that allows all that. Basically, the localhost port 8080 is then instead translated as gateway.ipfs.io.